In previous sections, we learned what mold is and the health effects. Now let's focus on what mold needs to grow. Most of the mold found indoors comes from outdoors because mold spores can easily float on gentle air currents. If spores land on a suitable organic material inside a building, mold can begin to grow. But mold needs certain things in order to grow and survive. Mold needs food and moisture. Other factors play in, but mold needs those two things. Moisture. Mold doesn't need a lot of moisture to grow. A little condensation in a bathroom around a windowsill, for example, can be enough. Common sites for indoor mold growth include bathroom tile and grout, that black stuff we see in the bathrooms, basement walls, and areas around windows and sinks. Common sources of water or moisture include roof leaks, condensation due to high humidity or cold spots in a building, slow drips at plumbing fixtures, central humidity or humidification systems, sprinkler systems, or floods. Molds have been found to germinate, grow, and produce mold spores in as little as 24 hours after the moisture intrusion occurs. It's very little time. Indoor relative humidity, RH, should be between 20 and 40% in the winter and less than 60% the rest of the year. Some experts recommend that indoor humidity levels in general should be 40 to 60%. Moisture is the most important factor influencing mold growth indoors. Controlling indoor moisture helps limit mold growth. Moisture is the key to controlling mold. Food. Besides moisture, mold needs nutrients or food to grow. Molds can grow on virtually any organic substance. Most buildings are full of organic materials that mold can use as food, including paper, cloth, plant material, even soil. Molds secrete digestive fluids that decompose the substrate, making nutrients available. Molds can digest some synthetic materials such as adhesives, paints, pastes. Molds can grow on inorganic materials such as concrete, glass, even stainless steel, because it actually grows on the dirt or dust that is present on the surface of those materials. Mold is a surface growth. Mold is a surface phenomenon. In most cases, temperature is not an issue. Some molds grow in warm areas while others prefer cool locations, such as mold on bread in your refrigerator. Molds grow well in an environment 40 degrees to 100 degrees Fahrenheit. Some experts have the range 32 degrees to 104 degrees. It's within 40 to 100 degrees Fahrenheit. The pH is between 3 and 8. Some mold species have been found to grow in hot springs with water temperatures above 120. Often, more than one type of mold can be found growing in the same area, although conditions such as moisture, substrate, temperature may favor one species of mold over another. Building science in relation to moisture and microbial growth. Microorganisms can be found in the air inside buildings, on a surface in a building, like on the floor, ceiling, or wall or furniture, and inside the HVAC system in a building. Many of these microorganisms come from outside. They come from decaying organic matter or moist earth, dirt. Microorganisms can enter the building by floating with the outdoor air that enters the building, or they can travel on people and animals who bring them inside. Microorganisms might be present on the building materials as the structure is being constructed. Oftentimes, inspectors will find building materials lying out on the ground at a new construction site. These materials absorb moisture and dirt, and these materials may then support mold growth inside the building after construction is completed. Mold is not desirable inside a building in an indoor environment, and it must be prevented, the growth. There are 3 reasons to prevent fungal growth inside a building. The 3 concerns. 1, the potential health effects to fungi and their byproducts. 2, the effect of mold contamination on the structural integrity of the building. 3, the negative aesthetic effects fungi can produce both visually and on the human olfactory senses. There are 4 factors that involve mold growth. The following are needed, essential, to have mold growth on surfaces. You need the mold spores. You need the mold itself. You need a temperature range between 40 and 100 degrees. You need food. Most surfaces contain nutrients for mold. You need moisture. So let's go to the mold itself, the spores. Spores are almost always present in outdoor and indoor air, and almost all commonly used construction materials and furnishings can provide nutrients to support mold growth. It's not possible to prevent mold from entering the interior of a building. How about temperature? Well, human comfort constraints limit the use of temperature control. Air temperature inside a building that is suitable for occupants is also good for mold growth. Most buildings are kept between 65 and 75 degrees Fahrenheit. This temperature range is suitable for mold growth. Some fungi can thrive in temperatures as cold as 15 degrees and some as hot as 122 degrees. It's not possible to prevent mold growth by limiting temperature. How about food? Well, a building is comprised of an abundant supply of nutrients for mold growth. There are several metric tons of building materials, food, in an average residential home. Fungi have been shown to colonize on drywall, wood paneling, wallpaper, ceiling tiles, carpeting and pads, furniture, insulated ductwork, clothing, and other building components, where the fungi break down the materials for food or use the dust that is collected upon a surface as a nutrient source. Dirt, dust, and soot on surfaces provide nutrients. It's impossible to prevent mold growth by eliminating or controlling food sources in a building. Moisture, therefore. Moisture is the primary factor in controlling fungal growth, mold growth in a building. Spores, temperature, food, time cannot be managed so as to control microbial growth, but moisture can. Moisture is the controlling factor. To understand how to find mold growth and prevent mold growth in a building, inspectors must study and understand building science. Building science, in relation to mold, is the study of building dynamics related to moisture intrusion. Buildings are dynamic environments affected by geographic location, season, weather conditions, HVAC system design and operation, moisture intrusion, pest colonization, and human activities. Building dynamics continually change and affect the conditions for mold growth. Moisture content. Moisture content, MC, is often expressed as a percentage. Or in terms of the amount of water in a certain volume. Mold requires moisture to survive, so protecting lumber and wood structures from moisture will prevent mold growth. Mold growth can be limited if the MC of wood can be kept below 20%. Below 17% of MC of wood, virtually no microbial growth will occur, even on the most susceptible materials. Southern pine dimensional lumber is typically kiln dried to a maximum 19% MC or less. Moisture content will be identified on the grade stamp. Keep in mind, moisture content is related directly to a particular substrate or material. Microbial growth is limited when the MC of gypsum board is below 0.6%, brick below 0.8%, wallpaper below 10.5%, concrete below 5%. There was a study that showed a moisture content a little greater than 5% permitted growth of penicillium and aspergillus on a ceiling tile in a laboratory. Molds and mildews are fungi that grow on the surfaces of objects, within pores, and in deteriorated materials. They can cause discoloration and odor problems, deteriorate building materials, and lead to allergic reactions in susceptible individuals as well as other health problems. Mold growth does not require the presence of standing water. It can occur when high relative humidity or the hygroscopic properties, the tendency to absorb and retain moisture, of building surfaces allow sufficient moisture to accumulate. Relative humidity and the factors that govern it are often misunderstood. This section of the course is intended to give mold inspectors, building inspectors, an understanding of the factors that govern relative humidity and to describe common moisture problems and their solutions. Relative humidity. Understanding relative humidity in a building is essential to controlling mold growth. Relative humidity, RH, is a ratio, expressed as a percentage, of the amount of moisture in air to the maximum amount the air can hold. Warm air can hold more moisture than cool air. RH is a factor in determining how much moisture is present in a room. But it is the available moisture in the substrate, not the RH in the room's air, that determines if mold can grow or not. Many sources recommend maintaining RH in living spaces below 60% to limit microbial growth. By keeping RH below 60%, one may assume that moisture content in building materials would be low. However, this assumption may be false, because mold grows on surfaces and in materials, not in the air. Therefore, it is the RH in the air adjacent to the surface, not the ambient RH, that must be lowered in order to control mold growth. Measuring a room with an RH at or below 60% may mean that the building materials are fairly dry, but it does not eliminate the possibility of mold growth, because local cold spots and water intrusion may allow the RH of the air adjacent to a surface exceed 70%. Moisture meters are essential for mold inspectors. They enable inspectors to identify damp areas that would otherwise not be evident. Infrared thermography cameras are praised for their ability to detect moisture that is not readily visible to the human eye. Water enters a building both as a liquid and as a gas, water vapor. Water in its liquid form is introduced intentionally in bathrooms, kitchens, and laundries, and accidentally by way of leaks and spills. Some of that water evaporates and joins the water vapor that is exhaled by building occupants as they breathe, or that is introduced by humidifiers. Water vapor also moves in and out of a building as part of the air that is mechanically introduced or that infiltrates and exfiltrates through openings in the building shell. A lesser amount of water vapor diffuses into and out of the building through building materials themselves. This sketch illustrates locations of moisture entry and how all those entry paths can add to the moisture gain of the building. The ability of air to hold water vapor decreases as the air temperature cools. If a unit of air contains half of the water vapor it can hold, it is said to be at 50% relative humidity, RH. As the air cools, the relative humidity actually increases. The RH rises as the air cools because cooler air has a lower moisture holding capacity, increasing the risk of condensation in the walls. If the air contains all of the water vapor it can hold, it is at 100% relative humidity, and the water vapor condenses, changing from a gas into a liquid. It is possible to reach 100% relative humidity without changing the amount of water vapor in the air, its vapor pressure or absolute humidity. All that is required is for the temperature to drop to the dew point. Relative humidity and temperature often vary within a room, while the absolute humidity in the room air can usually be assumed to be uniform. Therefore, if one side of the room is warm and the other side of the room is cool, the cool side has the higher RH than the warm side. The highest RH in a room is always next to the coldest surface. This is referred to as the first condensing surface, as it will be the location where the condensation occurs first if the relative humidity at the surfaces reaches 100%. It is important to understand this when trying to understand why mold is growing on one patch of wall or only along the wall ceiling joint. It is likely that that surface of the wall is cooler than the room air because there is a void in the insulation or because wind is blowing through cracks in the exterior of the building. This chart shows a relative humidity reading taken in a room will only give an accurate indication of the actual amount of moisture present if a temperature reading is taken at the same time. The chart shows that air at 70 degrees Fahrenheit and 40% RH contains approximately 0.006 pounds of moisture per pound of dry air, as indicated by that bold line going across horizontally. While the air that is at 50 degrees, 50 degrees, and 40% RH, same RH, contains approximately 0.003 pounds of moisture per pound of dry air, as indicated by the other line. Although both are at 40% RH, the 70-degree air contains roughly twice as much moisture as the 50-degree air. Let's talk about condensation in cold climates. The basic idea in controlling condensation due to vapor migration is to prevent warm, moist, laden air from contacting cool surfaces. In cold climates, condensation can occur within an exterior wall of a building when warm, moist indoor air flows outwards to cool air. This warm, moist air cools as it nears the outer boundary of the exterior wall, and the RH rises as the air cools because cooler air has a lower moisture holding capacity, increasing the potential for condensation forming in the walls. To control condensation in a building exterior wall in cold climates, install insulation to prevent large temperature differences between air and surfaces. Install air or vapor barriers on the warm side of a building envelope, and use ventilation to reduce indoor moisture levels below levels that allow condensation to occur. Condensation in hot and humid climates. Well, to control condensation in a building exterior wall in hot, humid climates, install insulation to prevent large temperature differences between air and surfaces. Install an air or vapor barrier on the exterior side of the building envelope, exterior side. Avoid impermeable vinyl or other wall coverings and use permeable paints and wall coverings on the interior surfaces of the exterior walls. HVAC systems should be producing net positive pressures on the inside of the building with respect to the outdoors to avoid entry of outdoor air inwards. And try to avoid cooling interior spaces below the average monthly outdoor dew point temperature for the climate in which the building is located. In some areas, this may not be possible. Many buildings incorporate vapor barriers in the design of their walls and floors. Vapor barriers must be located and installed properly, or the building may have moisture problems. A vapor barrier is a layer of material that slows or prevents the absorption or release of moisture from or into a wall or floor. Vapor barriers can prevent damp or wet building materials from drying quickly enough to prevent mold growth. Humidifiers. Moisture from humidifiers may support microbial growth on wet surfaces where moisture can condense during cold weather. Humidifiers that discharge small droplets of water from a reservoir of water are prone to supporting mold growth. Moisture accumulation inside a dirty ductwork creates a suitable environment for mold growth. The reservoir of a humidifier is usually contaminated in some degree. Humidifiers should be considered a potential mold growth source. Windows. In winter, windows are typically the coldest surfaces in a room. The interior surface of a window is often the first condensing surface in a room. Condensation on window surfaces have been historically controlled by using storm windows or insulated glass to raise interior surface temperatures. The advent of higher performance glazing systems has led to a greater incidence of moisture problems in heating climate building enclosures because the buildings can now be operated at higher interior vapor pressures or moisture levels without visible surface condensation on windows. In older building enclosures with less advanced glazing systems, visible condensation on the windows alerted the occupants to the need for ventilation to flush out interior moisture, so they opened the windows. Mold is commonly found on the exterior wall surfaces of corner rooms and cold climate locations. An exposed corner room is likely to be significantly colder than adjoining rooms, so that it has a higher relative humidity than other rooms at the same water vapor pressure. If mold growth is found in a corner room, then relative humidity levels next to the room surfaces are above 70%. However, is the relative humidity above 70% at the surfaces because the room is too cold or because there is too much moisture present, high water vapor pressure? The amount of moisture in a room can be estimated by measuring both temperature and relative humidity at the same location at the same time. Suppose there are two cases. In the first case, assume that the relative humidity is 30% and the temperature is 70 degrees Fahrenheit in the middle of the room. The low relative humidity at that temperature indicates that the water vapor pressure or absolute humidity is low. The high surface RH is probably due to room surfaces that are too cold. Temperature is the dominating factor, and controlling strategies should involve increasing the temperature at the cold room surfaces. In the second case, assume that the relative humidity is at 50% and the temperature is still at 70% in the middle of the room. The higher RH at that temperature indicates that the water vapor pressure is high and there's a relatively large amount of moisture in the air. The high surface relative humidity is probably due to air that is too moist. Humidity is the dominating factor, and controlling strategies should involve decreasing the moisture content in the indoor air. Finding mold in buildings. We know what mold is. We know what mold needs to grow. Now let's learn where to find mold in the buildings. A building can be a perfect place for mold growth if the building has construction flaws, systems or components that are damaged or inoperable, or delayed maintenance. Any part of a building that allows moisture to enter into the building materials creates potential for mold growth. Wooden components, drywall, carpeting, plaster, wallpaper, and many other building materials provide fertile conditions for mold growth when they are wet. Water-damaged materials provide sites for mold growth as well. Approximately a third of all residential homes in the United States have some sort of water damage every year. Where there is water damage, there's the potential for mold growth. When a home has mold growth, there may be large financial burden to correct the problem, as well as a serious health risk. So, number one, use your eyes. How to find mold? Use your eyes. A visual inspection is the most important initial step to finding moisture problems and mold growth in a house. A certified mold inspection includes a non-invasive visual examination of the readily accessible, visible, and installed systems and components, and at least, a few samplings for mold. Look for mold growth that is cottony, or may appear fuzzy or velvety, granular, leathery, and have variety of colors: white, gray, brown, black, green, even red. Some molds appear as discoloration or staining or some kind of fuzzy growth on the surface of building materials or furnishings. In your text, there's a general guide to performing an examination in a mold inspection. Check the general grading around the perimeter of the building. Look for unusual or problematic conditions. The ground should be sloped away from the building. Examine the downspouts and discharge of the roof water. Examine the storm sewer collection, the swales. Examine drainage areas, drainage systems. You're not required to inspect anything underground, though. No standing water should be present, even after a rainstorm, 12, 24 hours tops. The exterior siding materials and building envelopes should be inspected carefully. Flashing details should be installed, especially around windows, the header flashing, and doors. Trim around windows and doors should be watertight. Check the sealant conditions. We don't want air intrusion taking water vapor inside. Inspect for weep holes where required. Note the condition of the siding and the trim. Check reglets, counter, step flashings. Look for separations, gaps, and openings. All penetrations through the siding need to be sealed or flashed properly. The roof system needs to be inspected carefully. You're not required to walk on the roof, but it should be inspected from the ground or the eaves. Check for damaged or worn, deteriorated areas. Flashing details need to be installed properly. Flashing details are one of the most common areas for moisture intrusion. Improperly installed flashing. Check kick-out flashing installations, especially for stucco and EIFS. Observe any patching or repairs that may indicate something has been going on in the past. A roof condition in deteriorated or poor condition is a condition conducive to mold growth. Inside the building, check the walls, ceilings, and floors. Pay attention to paint surfaces. Look for patching and repairs. Look for water stains. Find watermarks. Use your moisture meter. In your report, note odors. Musty odors can indicate mold growth, likely indicate mold growth. Measure humidity levels, take temperatures, measure for wet, damp, or moist areas. That moisture meter shall be used in a mold inspection. Inspect the bathrooms and the toilet rooms. Run water at all the fixtures. Check for signs of leaks, prior leaks, water leaks, prior repairs. Check the exhaust fans where they discharge. Check for microbial growth around the bath fans, the toilet, inside the sink cabinet area. Bathroom carpeting is a contamination problem, and it can support mold growth. Carpeting in bathrooms should be removed. And check the sink cabinet, the shelf below the water lines and valves. Sometimes that's damaged. In the kitchen, all the appliances and fixtures should be operated and inspected. You're not looking at the performance of them, the efficiency of how well the dishes will get cleaned by the washer. You're looking for failures, water leaks. Look for stains and leaks under the kitchen sink, inside the cabinet. Check the area inside the cabinet for microbial growth. Check for water dripping from the dishwasher or refrigerator. The exhaust fan for the range should be discharging outside. Check the area around the exhaust fan and the filtering system for mold. One of the most important things that you can do in a mold inspection is check the HVAC system. Operate the circulating blower fan. Inspect the air filter system. An HVAC system with delayed maintenance is a condition conducive to mold growth. Dirty air filters can support mold growth if they become damp. Check the humidifiers for mold growth. Humidifiers can support mold growth. Note the method of how any dehumidifier is draining the water that comes from the dehumidifier. Inspect condensation or drip pans underneath air conditioning coils. Mold is often found on the coils themselves. There should not be any standing water on the condensate pan or on the water leak catch pan on the outside of the unit. Enter crawl spaces and check for humidity and moisture. Ventilation and insulation problems often support mold growth in underfloor crawl spaces. Exposed dirt floors should be sealed with a vapor barrier. Check for condensation on plumbing pipes and uninsulated ductwork passing through non-conditioned spaces, such as crawl spaces. Basements should be inspected for moisture intrusion and water penetration problems and water damage. Check for efflorescence on masonry walls. Carpeting an uninsulated concrete basement floor is not a good idea. Check sump pumps and their discharge. Check perimeter drainage channels or trenches for standing water. Check the bottom of the wooden stair stringers for water damage. Some older homes have those stair stringers that go right through the concrete floor and are resting on dirt. Check for leaks and condensation on all visible plumbing pipes and lines. Check the hot water source for leaks, drips, or discharge of water. A dripping TPR valve onto the floor is a condition that is moisture intrusion and a condition to support mold growth. Examine fire sprinkler systems, its main valves, pipes, sprinkler heads for leaks and drips. Enter any accessible attic spaces. Very important during a mold inspection. Check for properly installed adequate ventilation and insulation. Check for proper thickness in your geographical area. Examined enclosed structures around spas, whirlpools, swimming pools, saunas, and other areas of high humidity levels. Check dryer exhaust fans. Dryers need to exhaust outside, even electric ones. Be sure to note any dryers that discharge into one of those water pots where the surface tension of the water is supposed to collect all the lint. Big deal. Where did all that water in those wet clothes go? Inside the house. All dryers, electric, fuel-fired, need to exhaust that moisture outside and take with it the lint. Examine the proper ventilation of the exhaust of all combustion appliances, including fuel-fired heating systems and the hot water source. A backdrafting problem can introduce a lot of things, including humidity, into a house. Odors. Smell for odors. You may suspect mold even if you can't see it if a building smells moldy. You may suspect hidden mold if you know that there's been a water problem in the building and its occupants are reporting health problems and moldy smells. Some compounds produced by molds have strong smells and are volatile and quickly released into the air. These compounds are known as microbial volatile organic compounds, MVOCs. Because MVOCs have a strong, unpleasant odor, they can be the source of the moldy odor or musty smell frequently associated with mold growth. MVOCs are small molecules that don't tend to settle out on carpet and other surfaces as mold spores. They can pass through walls, allowing them to spread throughout the inside of buildings. However, like mycotoxins and enzymes, they can't be transmitted very far outside when exposed to sunlight, it's been said. A moldy odor suggests that mold is growing inside the building and should be investigated. The health effects of inhaling MVOCs are largely unknown, although exposure to MVOCs has been linked to symptoms such as headaches, nasal irritation, dizziness, fatigue, and nausea. More research is needed to determine whether there are any human health effects from non-occupational indoor exposures to MVOCs. A visual examination of a building includes reporting conditions conducive to mold growth. The following is a list of conditions that are conducive to mold growth. This list is for informational purposes only. It's not an all-inclusive list. Certain physical conditions may exist at a property that are not listed here. Certain activities or procedures that are beyond the scope of a standard inspection may be warranted at the discretion of the inspector. So, conditions to mold growth. Conditions conducive to mold growth. Water or moisture intrusion at carpeting in the corner of a below-grade basement. That's a perfect place to find mold. Standing water. Standing water is a condition conducive to mold growth. Water damage, puddles of water, areas with water stains, flooding, overwatered potted plants. Overwatered potted plants can spill water over the pot and introduce an excessive amount of humidity in the house. Water inside a sump pump bucket that's not moving. Standing water inside a perimeter drainage channel or trench. Condensation problems. Indoor humidity that is too high. Indoor surfaces that are too cold. Moisture movement through basement walls and the slab. Carpeting that is wet. Negative grading. Downspouts not discharging far enough away from the house foundation. Clogged or inoperative gutter system. A gutter filled with leaves is a condition conducive to mold growth. Dripping water valves. Steam radiators. Missing vapor barriers. Leaking gutters. Roof leaks. Plumbing leaks. Overflow of water from tubs, sinks, and toilets. Firewood stored indoors is a condition that's conducive to mold growth. The use of any type of humidifier, central humidifiers especially. Defects in systems or components that may allow water or moisture penetration. So if there's a defect in the siding installation and there's an open gap, that may allow water vapor to go right into the house, and with that condensation reaction between hot and cold and humidity, there could be condensation and mold growth within the wall cavity. A roof covering in deteriorated condition. A roof covering shingles that are 30 years old, deteriorated and cracked and missing pieces is a condition that is conducive to mold growth, and that should be reported. Improperly installed flashing. Defects in the plumbing system, such as a leaking dishwasher appliance. The HVAC system with a dirty air filter or a clogged condensate drainage pipe. improper discharge of exhaust from the clothes dryer, bathroom fan, or kitchen fan. Inadequate venting of the kitchen or bath humidity. These are things that a mold inspection should be reporting. These are areas of concern. These are conditions that are conducive to mold growth. The inspector shall perform a non-invasive visual examination of the building and shall report moisture intrusion, water damage, musty odors, apparent mold growth, and conditions conducive to mold growth. So let's do an inspection and look for moisture. I start with the roof. Inspector shall report the condition of the roof. I like to go up on roofs. You're not required to walk on roofs, but if the condition of the roof is in poor shape, then that should be noted. There's a tear in the shingle there. Take a look at the windows and the siding and the flashing where the dormers meet the shingles, and the flashing and header around the windows, and step flashing where the shingle meets the wall, that intersection there. A little bit of sealant there, that's good. So far so good. Skylight has flashing around it, no major damage. And then, oh, there's a bunch of shingles missing. So, this is a condition that's conducive to mold growth. It's a problem that allows water to enter into the attic space below. Roof is no longer water resistant, unreliable, so those shingles need to be replaced or corrected by a professional. Take a look at the chimney stack. There's the vent, ridge vent on the roof. Again, if you're not comfortable with walking on the roof, don't do it. Be safe. Flashing around the chimney stack, I like to inspect them. Look for kickouts. Flashing areas. Okay, on the ground, the downspouts look great. The grading is doing good. Downspouts are going underground. You're not required. There's one there. Not required to inspect underground drainage systems. Some general shots of inspection restrictions. The mulch up against the brick. The grading seems to be okay. The window wells are good. No signs of them filling up with water. Just some splash there on the stucco. There's actually a nice drainage thing there, getting to the nooks and crannies of the siding where different materials, siding materials meet and intersect. That should be sealed and watertight. Flashing up against the chimney stack, either side. Sealant around the windows. Look for weep holes according to the design of the window. There's my truck. Couldn't help it. Look at the entry door area where water may enter in those areas. Any penetrations like the dryer exhaust fan, the dryer exhaust hood. There's sealant around the door there, and there's weep holes underneath the deck. So we're doing really good on the outside up. We have an HVAC system, so we're going to do at least an air sample there. Missing trim around that window, prone to water penetration. Shake the electric meter. Sometimes it's loose and allows water to go behind the meter or follow the electric line into the panel. There's the HVAC system. Open up the blower door compartment area. Take a look, looking for signs of areas of concern. There's a UV light inside the air filter, which is great. However, it's just dirty, so there's delayed maintenance. Hasn't been serviced in a long time. That's a condition that's conducive to mold growth. There's the air conditioner condensate line. Follow that wherever it goes. Humidifiers are prone to microbial growth, fungal growth. Dust inside needs to be cleaned. Dust can collect moisture, and then there's a saddle flashing. It's not a great idea. Those leak. Follow the water lines and the sewer lines all over the place. There's a prior leak at the toilet there. I just follow the sewer lines. Downslope. Don't want any leaking sewer lines in the basement or in the house at all. just the visible stuff. You can't see everything. And you get to the water supply line, so you're going in the opposite direction through the main shutoff valve, which sometimes drips or is leaking. The meter is sometimes wet. I put my hand there. Hot water source has an expansion tank. Sometimes they drip. Look at the bottom of the hot water tank. The valves at the water source. The TPR, temperature pressure relief valve, sometimes is dripping. And then there's the water. We have water intrusion, water damage, water coming through the foundation wall. Now, is this mold growth? Is this visible mold? I don't know. It's apparent mold growth. It's apparent mold growth. Can't tell until you, there's my moisture meter, can't tell until you sample. And it's coming from this area here on the outside of the house. We looked at it already, didn't see anything wrong. So it must be somehow going in there and behind the brick, where the siding meets the brick. So then I started looking all over the place. Opening up the ceiling panels, taking a look above, in corners, nooks and crannies, looking for signs of moisture intrusion, because we have one area that was hidden, really. It's very difficult. I think I just came by it by mistake looking up. Cold ductwork sometimes produces condensation above the ceiling tiles. Looking for water leaks above the ceiling. There's the ceiling tiles below. That's the joist base, engineered trusses. Looking for water damage, any area of concern. Probing a little bit, see if there's any water damage anywhere. Checking out the sump pumps. Seems to be clean. A little damp, that's okay. Follow the discharge, make sure it goes outside. That's drywall dust on the side. Look at the basement stairs underneath the crawl space. Have a little moisture meter that probes the carpeting. Looking for a qualitative result. Check the air supply registers. Since the air filter of the HVAC system was dirty and delayed maintenance. Delayed maintenance on an HVAC system is a condition that's conducive to mold growth. At the bathrooms, we want to run water at all the fixtures. There's a Whirlpool tub. I fill them up. Some inspectors don't. It's up to you. Push on the tiles. Direct the water in different areas. Turn on the Whirlpool tub. And then look for access panels, and there aren't any. There aren't any access panels in this house. Other bathrooms, sometimes old metal sinks will deteriorate. No plumbing access panels. Take a look at the corners of the doors where the supply registers pushing up cold air, behind window drapes, looking for condensation along the windows. Condensation is moisture intrusion. The hoses of the clothes washer, the dishwasher, you want to run that. Look at the garbage disposal. Inside the sink cabinet, turn on the ventilation fan. So, in summary, we found missing shingles. That's conducive to mold growth, allows water intrusion. Dirty air filter, HVAC system, has delayed maintenance, hasn't been serviced in a long time, has a central humidifier, prone to fungal growth to some degree. Prior water leak at the toilet, active water penetration, water damage, apparent mold growth. Won't know until we sample. Diagnosis coming from somewhere over there. So we have areas of concern: moisture intrusion, water damage, musty odors, apparent mold growth, and conditions conducive to mold growth. So let's do another one. Visual examination of this building. Start with the roof and work our way down. The condition seems to be in pretty good shape. You don't have to walk on the roof. Evaluate it from the ground or the eaves on a ladder. Looking at the flashing, seems to be in pretty good shape. Sealed well, although I doubt if the flashing was actually installed properly. It's just heavily sealed. Filled gutters, those need to be cleaned out. A filled gutter can allow moisture intrusion into the building. Other areas of the roof, there's a flat roll roofing material that's in great shape, new. point is to check where the roof meets something else along the wall, the flashing areas. It's a critical area to inspect. If you can, look at the windows. Stucco is patched, looks okay. There's some header flashing there, some mold flashing above the windows. Exterior wood is absorbing moisture. That should be taken care of. Be careful, be safe. There's a live electric line right there. On the ground, the downspouts are not diverting water away. There's a valley there that's missing. There's stucco bulge, cracks, open gaps, allowing moisture to intrude and penetrate behind the stucco and do major structural damage to this house in that corner. You can put your hand underneath the stucco. That's an open gap. It's bulging out. Using my thumb to show the direction of the bulge. So it's a major structural problem, allowing moisture to come in. The siding is below grade. I think the structure bulged out. You can see the siding being compressed. The downspout is not diverting water away from the foundation. Foundation there. So you can see there's water damage. Major wood rot above the air conditioner unit. Follow the electric line from the meter into the foundation. Sometimes that allows water to penetrate. And in the crawl space, we have major water penetration. So that should be reported. Be careful walking around. Use personal protection equipment. Places flooded in the past. There's debris and building materials lying on the floor, which is food for mold. You have moisture, you have good temperature, and you have food. Around the boiler system, there's a lot of water. The boiler itself is leaking. That needs to be reported. The flue pipe has moisture coming down the chimney stack. That's moisture intrusion coming from the chimney stack. The jacket of the boiler shows a history of water problems. There's an active drip coming from the boiler valve. Check the well pressure tank and valves and water lines, and be careful again, that's asbestos on a duct pipe, plumbing pipe. The foundation is stone, so it's allowing moisture to come through. Behind the electric panel is moisture. These are chases and floor joist spaces that you can't get into, so you should note your inspection restrictions or anything else that you can't inspect that's listed in the standards of practice. Bottom of the basement stairs. Exposed dirt in a crawl space allows excessive humidity and moisture levels to increase in that confined space. Is that mold? I don't know. It's apparent mold growth. It's water damage for sure. Moisture intrusion. Is that mold? To be safe. Bathroom fixtures. Run water at all the fixtures. Open up plumbing access panels. Oftentimes you'll find problems there. On the interior, look for signs of patching and prior water problems. Black stuff in that corner there. And in that corner below the shelf there, apparent mold growth. That's actually water dripping from the ceiling tile. That's the chimney area, doing water damage inside the wall cavity. It's loose ceiling tiles, it's all wet. Behind the laundry is a good place to look for mold. Underneath sinks, run the sinks in the kitchen and look for active drips, and turn on ventilation fans in the kitchen. This old fan didn't turn on for me. So in summary of this building, we have a lot of areas of concern. Did a visual examination, found moisture intrusion, water damage, musty odors, apparent mold growth, and conditions conducive to mold growth. That should be all reported.